Hello, young scientist. My name is Aish Gupta, and in this video, we'll be seeing about torque. Okay, so this slide is about me. I am a BTech IT Roorkee student. So let's see what is a torque. Okay, so torque is represented by tau, which is tau naught sometimes. Okay, so let's say we have a particle. Okay, at P. Okay, and a force is applied on it in this direction. Okay, that is F, and let's say the position vector of this point P is your R. Okay, so torque is equals to your R cross F. Okay, now here the important thing is that this torque is given about a reference point, which is O in this case. Okay, so reference point about which the torque is calculated. So here this torque is calculated about point O. Okay, and also similarly this R will be also about this point O only. Okay, now this that because this you can see that torque is a vector quantity. Okay, this is the multiplication or cross multiplication of the two vectors. Okay, so the direction of this will be given by right hand thumb rule. Okay, so if you just look at it, so this R and F is lie in a plane. Okay, so if you apply the right hand thumb rule, you can see that the torque will be pointed downward. Okay, so always remember that this formula, that is the torque is equals to R cross F, and it is calculated about a reference point O in this case, and also care about the direction. Okay, now another way to find out the direction is just to realize the sense of rotation. Okay, so if this is an axis about point O, so this force will be rotating the this point P about a clockwise direction. Okay, if you just sense it, okay, this force will be trying to move it like this. Okay, so this torque will be then clockwise. Okay, and if it is clockwise, then if you just use your right hand thumb rule, then you can see that it is into the plane of the paper. Okay, that is something like this. Okay, the unit is equals to that of the energy, which is Newton into meter. Okay, or you can say joule. That is the same as the half mv square, the kinetic energy. Okay, now let's see some more torque formula applications. Okay, so we know that torque is equals to R cross F, and here are the three cases. Okay, the first case deals with the vector notation only, that is this is a point P, this is force that is applying, and this is the R vector, so torque will be given by R cross F. Okay, and you can see that in this case your R cross F will be pointing upward. Okay, because this R you will be extending here. Okay, remember this thing that the direction, you should calculate the direction carefully. Okay, you will not take it from R cross F from here to here, but you will extend R to here, so that the two vectors have the same common tails. Okay, and tail points actually. So then you will be using this right hand thumb rule. Okay, you can see that here R is behind the F, and here it is like this. Okay, so that's because here we are calculating direction, that's why I have extended this R to upward and made this diagram. Okay, do remember this thing. So the here you can see that the torque direction will be upward. Okay, now in the second case, you know that the torque, if you don't have to calculate the direction, then you can simply use the RF sine theta form. Okay, that is you just remove the vectors. Okay, and you will convert this cross product into RF sine theta. Okay, so RF sine theta, now there are two ways: either you can combine this F sine theta, or you can combine this R sine theta. Okay, so if you combine this F sine theta, then this will give you the perpendicular component of the force. Okay, that is this. So you will break up this force into two parts. Okay, this and this. Now theta is the angle between R and F. Okay, so again the angle between two vectors is given when their tail points are common. Okay, so you have to extend this R over here so that it becomes something like this, and then you will be calculated marking this theta. Okay, don't mark it something like this theta or this theta. Okay, mark it as this theta only, that is when they have same tail. Okay, now this torque will be then equals to your R F sine theta, and you, because you can break this F into two components, that is F cos theta and F sine theta, because f cos theta is parallel to r, so again the cross product of two parallel vectors is 0, that you already know. Okay, because sin theta is 0, and because this f perpendicular component is perpendicular to it, so you can just simply write it as r f perpendicular only. Okay, or sin theta 90 will become 1. Okay, so this torque will be either equal to rf sin theta or r f perpendicular. Okay, so this diagram will be something like this. Again, this torque will be upward, and the third way is to combine this r sin theta, okay, into r perpendicular, so as to give torque is equal to r perpendicular f, okay, or r sin theta f. So you can see this is the r, this is the angle between two vectors, so project it over here. Okay, this is line is parallel to f, so you can see that the perpendicular component of r will be this. Okay, and this will be the parallel component. Again, because these two will be parallel, so the parallel component of r will be giving torque as 0, so we will be concerning only with the r perpendicular form. Okay, so torque will be then equals to r perpendicular into f simply. Okay, so after you have calculated this magnitude in both the cases, you can calculate direction easily by applying the right hand thumb rule. Okay, so this is just another way to calculate the torque. Okay, so I hope that you are clear with the all the three diagrams. Okay, please try to understand these two concepts also. Even if you are not understanding, then try to draw the diagram. Okay, and then you can automatically clear yourself. Okay, don't just skip this. This is very important. Okay, this will help you in solving numericals, okay, easily. Now let's see what is the significance of torque, that is the physical significance of torque. So the most common thing that you see in the practical life or real life is that the door hinges. Okay, so let's say this is a door and these are the hinges. Okay, that is with these hinges it is attached to the wall. Okay, the door handles are always placed farther away from the hinges. Okay, that is the door handles aren't placed over here, here or here, it is almost placed to the edge. Okay, if you see this. Okay, so why it is always placed to the edge only? It's because so as to increase the torque for a given applied force. Okay, because you can exert with certain force with your hand. Okay, you can't exert very large force or very large force, so you can apply a specific force only. Okay, so for a given force you have to increase the torque. Okay, now if you just are near to, you know that torque is equal to rf sin theta. Okay, and let's say you apply the force perpendicularly. Okay, that is perpendicular to the radius vector. Okay, something like this. Okay, this is perpendicular. Okay, so sin theta becomes sin 90, which is equal to 1, so we can neglect that. Okay, so torque is equal to rf in that case, and you can see because f is constant, you can apply a definite force only. You see that torque is proportional to the distance of the perpendicular distance of this force from the axis of rotation. Okay, if kept f is kept constant, that is you apply the same force. Okay, so if you make the door handle over here, then you can see that r is very small, your torque will be small, and if you gradually increase it to the outward, you can see that r is increasing. Okay, so for the same given force, the torque is increasing with the increase in the perpendicular distance. Okay, so that's why you see that the door handles are applied at a far away from the axis or just at the edge. Okay, not itself on the edge. Okay, just near to the edge. Okay, so the more is the r, the more is the torque in this case. Okay, and the next thing is to note about the directions. Okay, so you can see that if you apply the force inward, okay, so the door will be opening inward, and you can see that in that case the torque will be upward. Okay, because from the sense of rotation it is going inward, and if you use the right hand thumb rule, you can see that thumb will be pointing upward. Okay, in this direction. And similarly, if you just pull the door, okay, and the door will be pulling towards yourself, and in that case if you apply the right hand thumb rule, the torque will be downward. Okay, so you can see that uh, this right hand thumb rule is the finding of the torque direction. Okay, so you can remember this two results. Okay, that is whenever you apply the force inward, then torque will be upward. Okay, and when you outward, the torque will be downward. Okay, in this case, so try to understand this slide properly. Okay, this has the various practical application which you may not find in any of the books. Okay, so try to understand the physical application when studying the physics. Okay, So let's solve the quick numerical quickly. Okay, so let's say the f is something like this weird notation type. Okay, acting on some point that is 2 comma minus 3 comma 6 meter. Okay, and you have to find the torque of this force about a point. Okay, remember that the torque is always given about a reference point, so the reference point here in this case is something like this. Now try it yourself. Okay, so the answer must be this. So I hope that you have tried it on your first. Okay, so the case given is that this, let's say this is the origin. Okay, this is the force applied. Okay, this is some arbitrary direction. Okay, no need to calculate the direction, just an arbitrary force. This is the point A and this is the point B. Okay, these are again two arbitrary points. No the real is this real application on the coordinate axis. Okay, I have just written to these 2 points. Okay, now force is acting at the point A, that is given to you in the question, and torque about the point B is to be calculated. Okay, so if you just apply torque is equal to R cross F and you just use the A point, then you will get the torque of this force about point O, but we have to find the torque of this force about point B. Okay, so we know that the torque is equals to your R cross F. Okay, where R is the distance of the position vector of the point from a reference point. Okay, so because generally we take it as from origin, now we will take it as from point B. Okay, so that is the position vector. uh, R is the position vector of point A with respect to B. Okay, otherwise it is with respect to origin, but here it is with respect to point B. Okay, so R A oblique B or A with respect to B is given as RA minus RB. Okay, so this is a fixed formula. Okay, remember this thing, where it is PAB equals to PA minus PB or any other variable. Okay, so whenever this form is written, you have to expand it to this form. Okay, now simply the two position vectors are given to you. Okay, and you just simply, what is a position vector? Position vector is simply the position of a point from the origin. Okay, position. Okay, in fact expressed in the vector form. Okay, so if this is the coordinates of a point, then you just simply place I, J and K. Okay, so it becomes the position vector. Okay, so if you just subtract it, you will get something like this. And if you just calculate the torque from R cross F formula, and I hope that you know the cross product over here. If not, then please do vectors first. Okay, and then you will be seeing that the torque we got is something like this, which is this only. Okay, don't forget to write the unit also. Okay, so the torque of this force about the point B is equals to this. Okay, remember that this for torque is different from the torque at origin. Okay, so try to calculate the torque at origin, that is torque is equals to R, that is 2 minus 3 comma 6 into F, that is this force. Okay, so you will get some different value. Okay, and see if the torque increases or decreases. Okay, so I hope you have understood that numerical clearly. Okay, now there are two other points important about the torque. Okay, so please try to understand these 2 points. Okay, if you are exhausted, then pause the video and take some rest and then understand. These two are very important slide that I will be dealing. Okay, so let's say you have an axis AA dash. Okay, and this the first point, it says that if force is parallel to the axis of rotation, that is AA dash, and the force intersects the AA dash axis. Okay, that is the force is parallel to this as seen in this case, or it intersects it at any other point. Okay, like this or like this. Okay, then the component of torque, remember this thing that we are dealing with the component of torque, not the torque itself. Okay, torque is a vector quantity, so the component of torque along the axis of rotation is 0. Okay, not the torque is 0. Okay, generally we say that torque is 0. No, the component of torque along the axis of rotation is 0. Okay, and the torque itself might not be 0, that is the torque if you calculate from this formula, then it might not come as 0. Okay, because you can see that R is this, F is this, so the torque will be in this direction. Okay, so you were in the to ask in the question that what is the torque about AA dash axis. Okay, so you know that AA dash axis will be the component of this torque about AA dash axis, which is 0. Okay, because it is perpendicular to the AA dash axis. Okay, so if you took the component as torque cos 90, it will be 0 simply. Okay, so here you can see that the torque isn't 0. but the component of the torque along a dash is 0. Okay, so remember this important result, that is the torque, if this condition meets, then the component of the torque along the axis of rotation is 0. Okay, so here is a better diagram, that is F is something like this, R is something like this, and this torque will be like this. Okay, because these two vectors are meeting head to head, so that's why we have to convert it into this form to calculate the direction. Okay, so second important point is the component of the torque along the AA dash axis is independent of position of point O, that is the reference point on the axis. Okay, that is, if you take this point O and calculate the torque about this point O along this axis, then you will get it as same as that of if O is over here. Okay, that is, if you first of all calculate the torque over here. Okay, and you get the torque as Rf, and the component which is parallel to this axis is Rf simply. Okay, so here you can see that if you change it to O dash, let's see what is the significance of that. So if you change it to O dash, then you can see that your position vector becomes R dash. Okay, and F is something like this, so the component of the torque will be something equal to like this. Okay, so here in this case, remember this thing, that this force is your in the plane, and it is something like this. Okay, that is like this. So these two are perpendicular, and you can see that if you apply right hand thumb rule, that the torque will be in this direction only. Okay, so the component of the torque and the torque itself is in the same direction. Okay, and in this also the force is something like this. So the if you just see, try to imagine it in your head, that is F is something like this in the plane, R is something like this, so the F will be something like this. Okay, so here the F is this, sorry, the torque is in like this. Okay, so here the torque will be equals to R dash into F simply. Okay, remember this thing, this F is not here. Okay, it is in the y axis direction. Okay, so let's calculate this torque. So torque about a dash will be equals to your R dash F, that is R dash F into this cos theta. Okay, that is the torque cos theta, tau cos theta, or it is simply R dash F cos theta. Okay, that is R upon cos theta. If you just apply some geometry over here, so this angle will be 90 minus theta, this is R dash, this is O dash, this is O, this is R. So converting R dash into R form, it will be R upon cos theta. Okay, into F cos theta. So the torque about a dash axis is equals to your R into F simply. Okay, that is R, R is this into F simply. Okay, so which is the same as that of this, because here torque about the component of the torque about the a dash axis is also Rf, and here you can see it is also Rf. Okay, so the change of origin or the reference point from O to O dash doesn't change the torque component about the a dash axis. Okay, but you remember this thing, that the tau changes because the direction of the torque changes. Okay, so here you can see that it is R dash F, and direction also changes. Here it is Rf only, and direction is in this direction. So the two important conclusion is that if F is in both the conclusions, the component of the torque is taken, not the torque is taken. Okay, so you have to deal with the component of the torque along the axis of rotation. So if is F is parallel to A dash, then you can see that, and also intersects it, then component of the torque is 0. And if you change the origin, that is O to O dash, and consider this as the reference point to calculate the torque, then also the component of the torque doesn't changes. Okay, so I hope that you have understood these two important points. Okay, even if you do not understood, then don't be demoralized. Okay, because these two are little difficult concept. Okay, so when you complete the rotation chapter, and then you will come again to these 2 points, then you can better understand them. Okay, so because for now it is very might seem very tough. Okay, so you can just leave it and come and understand it after you have completed rotation, but do understand these 2 points. Okay, these are very important. Okay, sometimes the question directly is asked based on this reasonings only, again you just get confused. Okay, so I hope that you have liked this video, and good luck, and thank you.